Hello, in this video I'm going to solve the problems in homework number 7. Simplify the following expression. Okay, as you see here I have the difference of two fractions, here I have the sum of three expressions, and then finally I want to multiply them. Okay, so I can do them case by case. For example, if you don't mind, let me call this one capital A for simplicity of writing, this one capital B. Okay, now let me calculate capital, or let me simplify capital A. Okay, so this is already in factorized form, this is already in factorized form, so the LCD is exactly the product of these two. So I will take the LCD, which is 1 minus x and 1 plus x. And the next step is I compare the denominator of the first fraction with my LCD. I see that I have this extra factor involved. So I will take the numerator of that fraction and multiply it by this extra factor. But the numerator and the extra factor here are the same. So when I multiply them, it becomes that expression squared. Yes. Okay, and then I see the minus sign here, so I put minus, and now I do the same thing, meaning that I compare this denominator with the denominator of the second one. I realize that I have this extra factor. This extra factor should be multiplied by the numerator of that fraction. Again, they are the same, so this becomes that expression squared. And as we learned during the lesson, you shouldn't touch the denominator because the denominator is already in factorized form, so that is good. I have to expand the numerator. Okay, so this is a binomial, an expression with two terms. I want to square it. It becomes the first one squared plus the two times the first one times the second one plus the second one squared. Okay, and then minus. I open a pair of brackets and I do the same thing for this one. Okay, so this becomes it becomes 1, the first one squared, 2 times the first one times the second one plus the second one squared. Okay, and now what happens? I open up this pair of brackets, the second one, so I would write 1 plus 2x plus x squared, but then you know that this minus sign here will go for this one, and this one. So the first term becomes minus 1, the second term becomes plus 2x, and finally the last term becomes minus x squared. And then everything divided by the denominator is 1 minus x, 1 plus x. But now what happens? This negative 1 and that positive 1 are gone. This positive x squared and that negative x squared are gone. I have 2x plus 2x, which is 4x. So this means that A is 4x in the numerator and the denominator is 1 minus x, 1 plus x. So this is the expression for A, and this is not possible to simplify it anymore. Okay, now I will start with expression in B. So here, this is already in factorized form. It is 4x, 4. Of course, you can factor it as 2 times 2, but it is not needed here, and the denominator is 1. So between 4x and 4 and 1, what is LCD? LCD is 4x itself. 4x itself is divisible by 4x. It is divisible by 4. It is divisible by 1, and that is the smallest expression possible. So this means that the common denominator for the second expression is just simply 4x. And I will do the same thing, meaning that I can compare this LCD with the denominator of the first fraction. No changes has been made, so I will copy and paste its own numerator. And then after that I have a plus sign, so I put my plus sign, I do the comparison once more. I compare 4x with 4. 4x has an extra x factor. This should be multiplied by the numerator of the same fraction, which again is x, so x times x becomes x squared. And now the denominator of the last one, which is not written, is 1. If I compare my LCD with 1, I see that LCD is 4x times larger than 1. That 4x should be multiplied by the numerator, which is x, and I have a negative sign here, so it becomes minus 4x squared. Now if I continue, this becomes 3x squared minus 4x squared becomes minus 3x squared, and then divided by 4x. But you see that the numerator can be factorized more, so this becomes 3. I factor a 3 out, and then the denominator is repeated, but hopefully you can immediately recognize the conjugate pattern here. So finally b becomes equal to 3. If I factorize it, it becomes 1 minus x times 1 plus x, and all over 4x. So this is the simplified version of b. Okay, now the question mark that I am looking for is what is a times b. So I have to multiply a by b. But what is a? A is 4x divided by 1 minus x times 1 plus x. And what is b? b is 3 times 1 minus x, 1 plus x divided by 4x. And you know that for multiplying fractions, we can simplify, if possible, in a vertical manner, and in cross manner way. So vertical manner does not work for any one of these fractions, but cross manner work in both directions. So you see 4x, this 4x and that 4x are simplified, so 1 is left from here, 1 is left from there. 1 minus x from here and 1 minus x are gone, so 1 is left from this one, 1 is left from that one, and 1 plus x and 1 plus x are also gone. 1 is left here and 1 is left there. So what is left only? In the denominator I have 1, 1, 1, so it becomes 1. And the numerator is just 1 times 3 times 1 times 1, which is 3. But of course 3 over 1 is just simply 3. So the final answer to this problem is simply 3. Okay, problem number 2, simplify the following expression. I have 3 fractions, I want to add and subtract them. So of course you know that I have to find the LCD of the denominators. To do that I have to factorize the denominators. The first one and the third one are first degree polynomials, so they cannot be factorized more. But the middle one is a quadratic polynomial, and you can immediately recognize the conjugate pattern here. But the problem is that if I just want to immediately factorize it, it becomes 1 minus 2x and 1 plus 2x. There is no difference between 1 plus 2x and 2x plus 1. However, there is a slight difference between 1 minus 2x and 2x minus 1. During the lesson, I told you that whenever you have expression, for example, I don't know, L minus M, but you need M minus L, the trick is to pull out a minus sign. Okay, so I will do that. I will first pull a minus sign out so that I can replace them, and the price of pulling a minus sign out will be that this addition will be subtraction. So the first thing that I will do is copy and paste more or less everything, except that in the middle term I would write a minus, and then I would replace the 4x squared and 1. I would write it 4x squared minus 1, and in the numerator it becomes 2 times bx plus ax squared, and then the next is minus ax squared minus b over 2x plus 1. Okay, but now if I want to find the LCD, 4x squared minus 1 can be factorized as 2x minus 1, 2x plus 1. Okay, so this means this expression itself is LCD because first of all it is divisible by itself, it is divisible by this, and it is also divisible by that. So I will take this as my LCD. Okay, so let me write it on the other line. So what happens, I put 2x minus 1 and 2x plus 1 as the common denominator. Then, as usual, I compare LCD with the denominator of the first one. I realize this is an extra factor. This extra factor should be multiplied by the numerator of that fraction. So it becomes 2x plus 1 times ax squared plus b. The next one is minus, and I will do the same thing. If I compare this one with the denominator of the second one, there is nothing extra, because indeed the middle term, the denominator of the middle fraction, is exactly the common denominator. So nothing has changed, so I just copy and paste its numerator. And then again I have minus, and then what I do, I will compare LCD with the denominator here. This time I see that this factor is extra. This extra factor should be multiplied by the numerator of that fraction. So it becomes 2x minus 1 multiplied by ax squared minus b. Okay, so now what I will do, I will actually don't touch the denominator and try to expand the numerator. But here you have to be a little bit careful because of these minus signs. Yes, so we know what to do. I don't touch the denominator. It becomes 2x minus 1, 2x plus 1 as it is. Then I start multiplying these two polynomials. I will multiply this here and there, and then I multiply this here and there. So this becomes 2ax cubed plus 2xb, and then plus ax squared plus b. The next one, I take minus 2 and multiply it here and there, so it becomes minus 2bx minus 2ax squared. But here I have to multiply this here, here, this here, and here, and when I found the answer, this minus sign will go inside and affect all the terms. If you don't mind, let us keep track of both of them simultaneously. What do I mean by that? I multiply this here, it becomes 2ax cubed, but I know that in the future the minus sign will affect that, so it becomes minus 2ax cubed. Yes? Let me repeat this for the next one. I am supposed to multiply 2x here, so it becomes minus 2xb, but there will be another minus sign coming in the future, so it becomes plus 2xb. Okay, I will repeat this one for that. So it becomes this one multiplied by that, it's minus ax squared, but another minus sign will come in, so it becomes plus ax squared. And finally, what do I have? I have minus 1 times minus b is plus b, but there will be a minus sign coming in, so it becomes minus b. Yes, so now I have to simplify the numerator as much as I can. For example, I see that 2ax cubed minus 2x cubed, ax cubed are gone. 2xb minus 2bx are gone. This ax squared with this ax squared becomes 2ax squared, but I have minus 2ax squared as well, they are gone. This positive b and this minus b are also gone. So in the numerator I am left with only 4xb. Yes? Sorry, 2xb. So this becomes, let me change my color. So this becomes 2xb divided by this expression. But you see, because there is nothing that I can simplify, I prefer to multiply it back. Of course, it doesn't matter. If you write this one here, that's also acceptable. So I multiply it back, so it becomes 4x squared minus 1. And that is the answer to this problem. Okay, problem 3. Simplify the following expression. Again, I want to add 3 fractions. Okay, so here I will also concentrate on finding LCD first. To find LCD, I have to factorize these denominators. Factorizations are very simple here, so let me just do them here for you. So x to the power of 3 minus x squared, I can simply pull out x squared. It becomes x squared times x minus 1. The second one, I will also do the same trick, because if I pull x out, it becomes 1 minus x squared. And if I factorize 1 minus x squared, it becomes 1 minus x times 1 plus x. But you see, I want to have x minus 1. So again, the same trick. Okay, so what I will do, I will change them. But remember, when I'm writing it down, I will change this plus sign to minus sign because of the price that I have to pay if I want to interchange them. Okay, so I will write it as x3 minus x squared, but remember that I will change this to a minus sign in the future. So again, sorry, that was not x2, that is x. So what I will do, I factor x out, it becomes x squared minus 1, but x squared minus 1 itself can be factorized using the conjugate rule. So this is the factorization. And then finally I factorize this by pulling x out. Yes, so now if I ask you what are the factors involved, you will tell me x is one factor, x minus 1 is one factor, and x plus 1 is another factor. These are the only factors involved in all these factorizations. But of course, the highest power of x, here the power is 2, here the power is 1, here the power is 1. So the highest power is 2. But the highest power x minus 1 here and here is 1, and no x minus 1 here. So the highest power of x minus 1 is 1. For the same reason, the highest power of x plus 1 is also 1. So LCD that I am looking for, let me write it here. So LCD becomes x multiplied by x minus 1 multiplied by x plus 1 with the highest exponents. For x is 2, for the other ones is 1. So this is your LCD. So now what I will write that this expression is equal to, still remember this is a minus sign because I interchanged them. So what I will do, I will write my LCD here, which is x squared times x minus 1 times x plus 1. And now I compare my LCD with this expression. Okay, but this expression, you see it here. So if you compare LCD with this expression, what extra factor you see? You see that x plus 1 is the extra factor, because this expression has x squared, this expression has x minus 1, but this expression does not have x plus 1, so x plus 1 is the extra factor. So that extra factor should be multiplied by the numerator of the first expression, so it becomes x plus 1 times 5 minus 3x. But in the original problem it was plus, but because of this change, I know that now this should be negative. And then I compare LCD with the middle one, which is this one, and you see that what extra thing I have just one x extra. Why? Because x plus 1 is x plus 1, x minus 1 is x minus 1, but my LCD has 2 factors of x in it, but this has only 1 factor of x. So I have 1 extra factor of x. That extra factor of x should be multiplied in the numerator. So it becomes x times x minus 7. And the next one is plus. Now again I do the comparison. I will compare this with the last denominator. X plus 1 repeats itself here. X also repeats itself here, but you know that you have 1 extra x. So if I ask you how many extra factors you see here compared to this, you will tell me x is 1 extra factor and x minus 1 is also 1 extra factor. So I have to take these extra factors and multiply it by the numerator of the third fraction. So this becomes 4 times x minus 1. Okay, and then you know the rule, so you just copy and paste the denominator and you expand the numerator. To expand the numerator, I have to multiply this here and there, this here and there. So let us just do it quickly. It's simple. So it's 5x minus 3x squared plus 5 minus 3x. For the middle one, I take minus x, multiply it here and there. So the first one becomes minus x squared, but the second one becomes plus 7x. And finally here, I take 4x, multiply it here and there. So this becomes plus 4x squared minus 4x. Okay, now let us simplify as much as we can. So what I have 5x minus 3x, so far remember 2x, but I have 7x, 9x, 4x is gone, 5x is left. Yes, so this becomes 5x. The next one, I have 3x squared minus 3x squared here, and minus x squared here, minus 4x squared, and I have positive 4x squared. So x squared is completely gone. Yes, what else I have? I have a plus 5. So I would write plus 5 here, and then copy and paste the numerator. And now you see why we actually don't multiply the denominator, because to simplify one single fraction, I need the numerator and the denominator in factorized form. Okay, and now you see that in the numerator I can also pull a 5 out, which is very useful here because it will reveal a factor which will be cancelled by one of the factors in the denominator. So what I will do, I take this one off, take this one off, this is 1 times, this is 1 times, and then what is left in the numerator, 5 times 1 is left, in the denominator x squared times x minus 1 is left. Nothing can be simplified anymore. This is why I prefer to multiply the denominator. Of course, if you keep it in that way, that is completely okay. So it becomes x to the power of 3 minus x to power 2. So this is the simplified version of this expression. Okay, problem number 4, we're supposed to simplify this expression. So you see that this expression is supposed to be divided by this expression. Okay, I will prefer to do them separately and glue them together at the very end. Okay, so and for simplicity of writing, as I did for the first problem, so let me call it capital A for simplicity of writing, of course, and capital B, and then I start subtracting the fractions in capital A. Of course, here it is very clear that the LCD between these two is just multiplication of these two expressions. So let me write the LCD here, which is y minus a and x minus y. And then, as always, I compared my LCD with the denominator of the first fraction. I see that I have this extra factor. This extra factor should be multiplied by the numerator of the first fraction, which coincidentally is the same as the extra factor. So then it becomes x minus y squared. And then after that I have a minus sign, and I repeat the process, meaning I compare my LCD with the denominator of the second fraction. I see that I have this extra factor should be multiplied by the expression in the numerator. Again, coincidentally, they are the same, so it simply becomes y minus ax squared. I really recommend you to use rules that you know as much as you can. I have seen some students, of course, write these 2 times and multiply them. Of course it will work, but I really want you to learn to use the rules as much as possible. So here I will use the squaring rule. The squaring rule tells me that the first one squared minus 2 times the first one times the second one and plus the second one squared. Minus, I open a pair of brackets. Within the pair of brackets, I expand the second expression using the squaring rule again. The first one squared minus 2 times the first one times the second one and plus the second one squared. And as usual, we do not open up the denominator, we keep it in factorized form. And now what I will do, I will copy and paste the denominator, and I will open up the numerator. X squared minus 2x plus y squared, I just copy and paste. As usual, you have to be careful about this minus sign, which goes here, here, and there. So then it becomes minus y squared, but plus 2ya minus a squared. Then I try to simplify the numerator if possible, which in this case is, for example, minus y squared and y squared are gone. Is there something more left? No. So I simplify that. So it becomes x squared. In anticipation of what is coming, if you don't mind, let me write minus a squared here, and then I would write minus 2xy and plus 2ya. Okay, and then denominator. But the point of this problem, the reason actually I put here, because I was seeing ahead of me that I will use grouping method to factorize the numerator even more. Why I did that, I want to take these together and I want to take these together. Okay, between here I can use the conjugate rule. So let us see why this grouping is successful. It might not be clear now, but it becomes clear shortly. So if I factorize the first two terms in using the conjugate rule, the answer is x minus a times x plus a. But what I will do here, between these two, I can factor 2y out. But if I factor 2y out from the first one, minus x is left, from the second one is y is left. So if I pull 2y out, it becomes a minus x. But you see, I need x minus a. We practiced about this a lot. Whenever you need a minus x, the other y, whenever you need x minus a, but you get a minus x, the trick is to pull out a minus sign. So instead of pulling 2yi, I will pull minus 2yi. Sorry, minus 2y. So this becomes minus 2y. And the first one becomes x, the second one becomes minus a now. And then I copy and paste the denominator. Okay, let me explain a little bit more what I did. So, these four terms are left. What I did, I wrote x squared here. In anticipation of what I'm going to do, I decided to write minus a squared here. And then instead of, I just took these two and put them here. Here I use conjugate rule to factorize it in this form, but as I explained why, between these two, instead of just simply factoring 2y out, I decided to factor minus 2y out. Is my factorization correct? Yes, because if now I multiply minus 2y back here, I will get this term. If I multiply it here, I will get this term. That's correct. But what is the benefit of this way? Because now I can see that this grouping is successful, because now a common factor, which is x minus a, emerges. And I can pull that out. So this becomes x minus a. And what is left from the first one, x plus a is left. And what is left from the other one, minus 2y is left. So it becomes x plus a minus 2y. But I am a little bit unfortunate here, because even though I factorized the numerator, I was not lucky enough to see that something is being simplified. Yes? Okay? This is in factorized form, this is in factorized form, but nothing can be simplified. It seems that I have wasted my time because of this factorization, because nothing can be simplified. But my impression is that might be this factorization will be used when I want to do this division. I will paste it here, and this is my b, and I will continue simplifying it. But again, the common denominator is this product, x minus y, y minus a. I compare my LCD with here. I have extra factor y minus a, which I have to multiply it here. So it becomes y minus a times x minus y minus 1. And then I have a minus sign here, so it becomes minus. Comparing the LCD with this one, I have this extra factor should be multiplied here. So then it becomes minus x minus y multiplied by y minus a minus 1. And as usual, I will not touch the denominator, but I will open up the denominator. And then this is so simple. For example, I multiply this here, here, and there, and then I will multiply a here, here, and there. So let us do it quickly. So this becomes yx minus y squared minus y minus ax plus ay plus a. I will do the same thing here, but as I told you, there is a minus sign here. I have to be careful. For example, x will be multiplied by y. It gives me plus xy, but in the future a minus sign will go in, so it becomes minus xy. Again, x multiplied by minus a becomes minus ax, but in the future a minus sign will go and affect this term as well, so it becomes plus ax. Okay. So, and if you don't mind, let me do this quickly. The next one becomes minus x, a minus sign will go in, it becomes plus x. That is finished. I go here, minus y times y minus y squared. There is a minus sign here coming later, becomes plus y squared. And then I have minus y times minus a, which is plus ay. A minus sign coming here becomes minus ay. And then finally, minus y times minus 1 is plus y, a minus sign comes in, it becomes minus y. And let me increase this fraction line here. Okay, so as usual, I try to simplify as much as I can. Immediately I see that this yx and minus xy are gone. Minus y squared and y squared are gone. Positive ay and negative ay are gone. What else? Positive ax, negative ax are gone, and what is left for me? A minus y is left here, a minus y is left here, a is left here, so it is a minus 2y. Is there anything more? Oh, sorry, x is also left here, so it becomes x, do you agree, minus 2y plus a, and then I have it here, x minus y, y minus a. Okay, so now this is your a and this is your b. I am supposed to divide a by b. So let me, and you know that for writing a by b, I write a the same, I change this to multiplication, and I write the reciprocal of b. But if I ask you what is the reciprocal of b, you will tell me that is the fraction in which the numerator and the denominator are swapped. Okay? So a divided by b becomes a multiplied by 1 over b. But if I ask you what a is, you will show me this. So it becomes x minus a, x plus a minus 2y divided by y minus a times x minus y, and then multiplied. What is y? 1 over b. It is the same fraction, but the numerator and the denominator are swapped. So the denominator will go to the numerator, and the numerator will go to the denominator. But of course, I cannot simplify vertically. I cannot simplify vertically, but I can simplify in cross-manner way. How? A lot of things actually will be cancelled out, as you will see here now. For example, this y minus a and that y minus a are gone. So one is left from here, one is left from here. X minus y here and x minus y here are gone. So one is left here, one is left there. But this term is also cancelled with this one, okay? Because they are exactly the same. X, x, a plus a plus a, minus 2y minus 2y. So they are actually identical. So this means that this is also gone. So if you see, only x minus a survives. So the answer to this problem is actually very simple in form. It is x minus a. Okay? Okay, now problem 5, solve the following equation. Okay, so this is a rational equation. In order to do that, I need to find the LCD between all denominators and multiply both sides by that LCD to get rid of fractions. Of course, this is not the unique way of doing it, but this is one way what I think it's a very good way. But before doing that, I need to factorize. But these two are already factorized. The only thing that I have to factorize is this one. Factorization of that is very simple. 2x squared minus 2x. I just pull 2x out. The first one x is left. From the first one x is left. And from the second one minus 1 is left. So now if I ask you what is LCD between these three expressions, you immediately show me that this one is the LCD. So what I will do, I multiply the left hand side by this LCD. Yes. And I also multiply the right, because whatever I do on the left, I have to do on the right if I want to keep the equality. And of course, the only thing that I will do, I write the numerator, but I write the factorized form of the denominator. Okay, now imagine, because this expression should be multiplied here and should be multiplied there. So let me just do it for you. You can do it in your head, but let me write it for better understanding. So I multiplied by the first fraction, and then plus I multiply it by the second fraction, yes. On the right hand side, I just keep it for the time being because I want to start simplifying everything together. So let me also put a dot here. Okay, now here this x minus 1 and that x minus 1 are cancelled. 2x is left, x plus 2 is left, so I have to multiply it here. So it becomes 2x times x plus 2, and then I have plus sign, and I do the same thing here. Here 2x and 2x are gone. What is left for me is this, should be multiplied into the numerator. So this becomes x minus 1 times x minus 4, and on the right hand side everything is gone. Actually 2x and 2x are gone, x minus 1 are gone, so 4 is left. So it means that instead of solving an equation with 3 fractions, I solve an equation without any fractions. And in principle, solving an equation without a fraction is simpler than solving equations with fractions. So that is the whole point of multiplying both sides of the rational equation by the LCD. Okay, but now you know what to do. I multiply this here, I multiply these two, and then simplify this equation. So it becomes 2x squared plus 4x. Here there are 4 terms to consider: x times x, x squared, x times minus 4, minus 4x, minus 1 times x, minus 1 times minus 4 plus 4. And then I know that because the quadratic term survives, eventually I have to move everything to the left and use either PQ or ABC formula to anticipate that. I just put minus 4. I moved actually this 4 to the other side, and it becomes 0. And now I have 2x squared here, x squared here, so it becomes 3x squared. And now I have 4x, and 4x are gone. Minus x is left. Yes, and then you see that 4 and 4 is also gone. So I will get this equation. So let me double check. So these two are gone, minus x is left, 4 and 4 are gone. That's also correct. Yeah, that's correct. Now, of course, you can use ABC or PQ formula to solve that, but factorization is the best way here. So I factor 1x out, so it becomes 3x minus 1 equals to 0. But now this number and that number are multiplied, the answer is supposed to be 0. The product of two numbers equals to 0. So this means either the first one is 0 or the second one is 0. Okay, so let me draw a vertical line here and continue here. So it is either x equals to 0 or 3x minus 1 is equal to 0. So this means that either x equals to 0 or x is equal to 1/3. But you remember in the lesson that you shouldn't be in a hurry when it comes to rational equations. This one, you can see this is a false root. Why? Because if I take it with me to the first original equation, when I put x equals to 0, I will not have any problem here in the denominator because it becomes -1. -1 is acceptable as a denominator. But this one becomes 0, and whenever the denominator becomes 0, actually I am in trouble. So this one is a false root. It is essential to understand that. And 1/3 doesn't impose any problems. It doesn't make this one 0, it doesn't make this denominator 0, it doesn't make this denominator 0 either. So it means that it is the only solution to this rational equation. Okay, finally the last equation. Let alpha and beta be solutions of the following equation. It's a rational equation again. Then alpha plus beta minus alpha beta is equal to what? Okay, so it is clear that I have to solve this rational equation. For a rational equation, as we learned again in the previous problem, I have to find the LCD of all denominators. To find LCD, I have to have all denominators in factorized form. This is a first degree polynomial, it cannot be factorized more. This is a first degree polynomial, it cannot be factorized more, but this can be factorized easily. And let me write the factorization just below itself. So this is very famous, so I put one x here, another x here. I ask myself, I need two numbers with the sum +5 with the product +6. It's very easy to see that these numbers are just +2 and +3. Okay, so now if I ask you between this and that and this, what is LCD? Of course the LCD is this orange expression itself. So I multiply both sides by LCD. The philosophy is I want to get rid of all fractions. So I would write x plus d times x plus 3, and then I multiply it by the left hand side. Okay, but when I want to write the second one, I copy its numerator. But for the denominator, I write the factorized form. It's always simpler. And of course, on the right hand side, what I will do, I would do the same, x plus 2, x plus 3, multiplied by x plus 2 over x plus 3. And of course, as before, this should be multiplied here, this should be multiplied here. So let us do that. You can do it, of course, in your head, and I believe that is even better. But let us just do it here. X plus 3, x plus 2, and then minus x plus 2 times x plus 3 multiplied by x squared minus 75 over x plus 2, x plus 3. And let me just copy and paste once more everything on the right. Of course, you can simplify it if you don't like to write so much. Okay, but then here x plus 2 and x plus 2 are gone. X plus 3 survives here, x plus 3 survives here. I have to multiply them. But x plus 3 times another x plus 3, of course, it becomes x plus 3 squared. And then I have this negative sign. So this one and that one are gone. So let me change my color. So this one and that one are gone. This one is also gone. So what is left? A minus sign is left and this expression. But be careful, this minus sign is not just for the first one, it's for the whole expression. So let me put it in a pair of brackets, or you can take care of it mentally. So now here, on the right hand side, x plus 3 is the only one that survives, cancels. This x plus 2 and x plus 2 are left, but then when I multiply them, it becomes x plus 2, let me change my color, x plus 2 to the power of 2. And of course you know what to do. You expand the left side by squaring rule. The first one squared 2 times the first one times the second one, and the second one squared. But this minus sign goes here and here. So it becomes minus x squared plus 75. On the right hand side I use the squaring rule again. The first one squared 2 times the first one times the second one, and plus the second one squared. Okay, now what happens? On the left hand side, this minus x squared and that one are gone. So what is left for me is just simply 6x. 9 plus 75 is 84. On the right hand side, I am left with x squared plus 4x plus 4. And this is a quadratic equation, so let me move this to the other side. Let me also move this to the other side. So it becomes x squared. 4x minus 6x is minus 2x. 84 goes to the right, becomes minus 84. I have a plus there, 4 there. It becomes minus 80 equals to 0. Okay, now you can use PQ formula, for example, to solve this, or ABC formula, or factorization. It doesn't hurt if we practice our factorization, but it is not necessary. PQ formula is quite okay for this one, because this number is 1 and this number is even. Whenever this is the case, PQ formula is better. But factorization is probably better than both of them. So I would factorize it. I ask myself, I need two numbers whose product is minus 80 and the sum is minus 2. So which famous numbers have the product 80? 10 and 8, yes? And they can be adjusted in a way that the sum becomes minus 2 as well. How? By putting negative sign for 10 and positive sign for 2. Am I right? Double check always, don't forget. So minus 10 plus 2 is minus, sorry, not 2. So this is why I'm saying that's always good to double check. This is 8, sorry. Okay, let us double check again. So minus 10 plus 8 is minus 2, that's correct. Minus 10 times 8 is minus 80, that's correct. So that is correct. So it means that I have two answers. One of them is 10, the other one is minus 8. So one of them is indeed alpha, one of them is beta. And because this is symmetric with respect to alpha and beta, it really does not matter which one is alpha, which one is beta. You can call, for example, the first one alpha, the second one beta. So the question mark is alpha plus beta, which is 10 plus minus 8, minus alpha times beta, minus 10 times minus 8. So the first one becomes 2, the second one becomes plus 80, so the answer is 82. Okay? But a shortcut is actually also good to know. Let me write it here. If you remember during the lesson, I told you that if I have a quadratic equation, one way, of course, to find, and let us say x1 and x2 are the roots of this equation. If I ask you, can you find the sum of them? Of course you can. You can solve the equation, find the roots and add them up. But if you remember from the lesson, there is a very nice formula here. x1 plus x2 is always minus the coefficient of x divided by coefficient of x squared. And the product of them is equal to c over a. The constant term over the coefficient of x squared. These formulas are named after French mathematician Vieta, which you spell it like this. So these are called Vieta formulas. If you have, these are in the book, but if you know them by heart, of course you can use them. Here, for example, the question mark is what is alpha plus beta minus alpha beta. Okay? But what is alpha plus beta? Alpha plus beta is the sum of the roots. So according to Vieta formula, it is minus b. b itself is minus 2, so it becomes minus 2 over 1, which is 2. Okay? And then minus minus c over a for the product. Alpha beta is the product, so it becomes minus 80 over 1, so it becomes plus 80. So you can immediately get 82 again. So if you know Viet formulas, it would be a little bit simpler for you to do this calculation. Otherwise, of course, you can solve the problem and find the sum and the product. But here it was not problematic if you don't use Viet formula, but sometimes the roots of a quadratic equation are actually not very friendly. Here I have the roots 10 and minus 8, they are quite simple. But if the roots are involved with the square root signs and things like that, then of course calculation becomes a little bit harder if I want to calculate the sum and the product by first finding the roots and then calculating the sum or the product. If you know the Viet formulas, you can immediately do that. Okay, I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.